All right, so we want to find the value of sine of theta for the following angles. Okay, so for each of these, I'm going to draw a picture so you can see what it looks like, and I want you to know where these angles came from, what the values of the angles look like on the unit circle, and then we're going to talk about where the values of the trig functions at those angles came from. And they all come from just some triangle geometry that we're going to do. And once we've established these values, then those are just values that you're going to need to memorize. Okay? So, sine of theta. We want to find that for 0. We want to find it for pi over 6 and for all of these different angle measures. So let's first just talk about 0, okay? If I have a unit circle, okay, here's a circle, and on that circle, we're always starting here. Something else that I failed to mention earlier is that because this is a central angle, this is actually the x-axis, and this is the y-axis, and this is the origin. This is the point 0, 0. So if this is a unit circle that we're talking about, then the radius has a length of 1, which means that this point right here is the point 1, 0. And this point up here, because this is still a radius, this distance right here is still a radius, this is the point 0, 1. And so if we have sine of 0, remember that sine represents the y-coordinate around the outside of this circle. It should be on the red, a point that's on the red part of the circle, where we have no angle at all. No angle at all is actually this angle. It's the x-axis. So where am I on the circle when there is no angle at all? Well, my y-coordinate is 0. What's the y-coordinate of the point on the circle when I haven't created any angle at all? Okay? So sine of 0 is 0. Now, I'm going to skip to pi over 2. Okay? Pi over 2 is the same thing as 90 degrees. And so sine of pi over 2 represents the y-coordinate of the point on this circle, this red circle, when I have an angle of 90 degrees. Well, the point is this one up here on the y-axis, and here's the y-coordinate, it's 1, and so sine of pi over 2 is 1. And again, the idea here isn't difficult. It's just notation is new. The notation of both trig and radian measures. These are both new concepts to us, but hopefully soon enough you'll get a better understanding of like that pi over 2 is 90 degrees. Pi is 180 degrees, so pi over 2 is 90 degrees, which means pi over 4 would be 45 degrees. And so all of these angle measures that are listed here in terms of pi are actually also very common degree measure angles too. So 0 radians is 0 degrees, and pi over 6 is actually is 30 degrees. Okay, and pi over 4 is 45 degrees. Pi over 3 is 60 degrees. And if you don't believe me about any of these, you can do that conversion. If I just multiply pi over 6, this is in radians. If I multiply it by 180 degrees over pi radians, the pi's cancel. 180 divided by 6 gives me 30 degrees. So pi over 2 is 90. Okay, pi is 180. And then 3 pi over 2 is 270, and then 2 pi is 360 degrees. So when I draw each of these pictures, you can see that clearly the y-coordinate of this point where the angle is 0 is 0. and the y-coordinate of the point where the angle is 90 degrees, or pi over 2 radians, the y-coordinate is clearly 1. And so now let's find that for some of these more obscure ones, like pi over 6. Okay, pi over 6 is 30 degrees. And so when we draw a 30-degree angle coming off of this, I did the best I could there. Let's say this is about 30 degrees, okay? A 30-degree angle actually creates a triangle here, a right triangle. Here's my right triangle, okay? This length right here, the base of this triangle, is the x-coordinate. The height of this triangle is the y-coordinate of this point that I'm going to draw in red. So the point in red, the x-coordinate of it is the distance from this thing from the y-axis is what we call x. And so that's the x-coordinate. And then the height of this thing is the y-coordinate. The distance from the x-axis is the y-coordinate. And so I really just want to find the height of this rectangle, this triangle here. And the triangle has a radius of 1 because this is a unit circle. We know that this angle here is 30 degrees. And since this angle is 90 degrees, that makes this angle up here 60 degrees because the inside of a triangle has to add up to 180 degrees altogether. So knowing that this is a special right triangle, we're going to talk about how we would find the value of this height. And so I'm going to do that by drawing another segment here. I'm going to do my best mirror image of this thing. So this is now this triangle right here. This triangle right here, let me outline it in red. This triangle right here, it might not look like it, but I'm actually trying to draw. This is an equilateral triangle. Okay, this side is 1, and then this side right here is also 1. And if this is truly, this is a little bit off center, but if this is truly 1 and this is sort of symmetric about the x-axis, then that makes this height right here 1/2. Okay. So the y-coordinate of this point right here is 1/2, which is what I was looking for, right? So I'm looking for sine of pi over 6. Sine of pi over 6 is 1/2 because the y-coordinate here is 1/2. Okay? Now, I can skip to finding pi over 6, or pi over 3 rather. Pi over 3 is up here, and that's when this angle is that's when this angle right here is 60. So that's actually sort of the same thing. If this one's 60, then that means this angle here is 30. So we already know that this distance is 1/2, but we need to find this height, which is the same as finding x in this first triangle. Okay, so let's just draw a triangle, an equilateral triangle. Okay, I did the best I could there. Let's pretend this is equilateral, and so that means we know that this is 1 and this is 1, which makes this 1/2 and this 1/2. Okay, so using the Pythagorean theorem, we can actually find the length of this side of the triangle, because this is like one leg. Let's call this A. Okay, and we know that a squared plus b squared is equal to c squared. And so that means a squared plus 1/4 is equal to 1. So that means that a squared is equal to 1 minus 1/4, which is 3/4. And so a is equal to the square root of 3/2. So the height here, this height, which is the y-coordinate of this point, is root 3 over 2, which we already established the x-coordinate here was 1/2. So that means the x-coordinate here was root 3 over 2, which, going back to here, that means that sine of pi over 3 is root 3 over 2. Okay? So now let's do sine of pi over 4. Now pi over 4 is the same thing as 45 degrees, pi over 4 radians. And at this point on the unit circle, this height right here and this width right here are actually the same length. So let's call this A, let's call this A as well, because they're the same. And we know that this length is 1 because it's a unit circle. And so using the Pythagorean theorem again here, we know that a squared plus a squared equals 1 squared. So that means 2a squared equals 1. So that means a squared equals 1/2. And that means that a is equal to the square root of 1/2, which we rationalize to be root 2 over 2. So this point right here on the unit circle, this red point right here, has an x-coordinate of root 2 over 2 and a y-coordinate of root 2 over 2. And so going back to this question to find sine of pi over 4, sine of pi over 4 is the y-coordinate of the point on the circle that is created by the segment that cuts through this at a 45-degree angle. And so that is root 2 over 2. Cosine of pi over 4 would also be root 2 over 2. And if we keep doing this, if we keep going around, we get this complete unit circle, which I have here for you. And you can see these values are exactly what I just showed you, and these are always true, and these all come from these special right triangles that were created, and we just did a little bit of geometry with it. What I'd like you to understand is that you have to memorize this, and probably the easiest way to remember is that if we're starting here, if we talk about sine and we're starting at 0, we start at 0, right? And then the next value is 1/2, and then the value above that is root 2 over 2. The value next is root 3 over 2, and then we have 1 as a y value at the top of the first quadrant. So the first quadrant is really what you want to memorize, because all the rest of the quadrants follow from that, and we're going to talk about that in just a minute. But the easiest way to remember this is that this is 0 over 2, this is root 1 over 2, this is root 2 over 2, this is root 3 over 2, and this is root 4 over 2. Root 4 being 2, 2 divided by 2 is 1. And so it's just a pattern. It's just increasing by, we're starting with the square root of 0, square root of 1, square root of 2, square root of 3, square root of 4, all over 2. So all of these values are something over 2, and we're starting at the square root of 0, square root of 1, square root of 2, square root of 3, square root of 4. Hopefully that will help you, that little trick will help you in memorizing this unit circle. But yes, you do have to memorize this unit circle. And I've attached a separate drawing of this on Blackboard in the notes section for you to download. I recommend either taking a picture of this screenshot and putting it as the background of your phone, or framing the PDF that's on Blackboard that you can print out and like put it in a physical frame. Stare at it before you go to bed at night so that you remember it. And that's really the best advice that I can give.